We will now solve problems using the conditions of equilibriums we developed earlier in the lesson. Let's start with this simple problem. A uniform meter stick pivoted at its center has a 100-gram mass suspended at the 25 centimeter position. At what position should a 75-gram mass be suspended to put the system in equilibrium? What mass would have to be suspended at the 90 centimeter mark for the system to be in equilibrium? Well, let me see if I can show this arrangement to you. Where here I have pivoted a meter rule at its center of mass. Now the center of mass is about 50 centimeter. This is the pivot point. If I apply a force on the right, it is going to rotate about the pivot point. And axis, you can see I just touched it and it sort of began to rotate. Now what is given? A 100-gram mass. I have a 100-gram mass here. It is suspended from this 25 centimeter mark. Now, starting from here at 0, 10, 20, and I'm going to suspend this at the 25 centimeter mark. And there it is. This is the 25 centimeter mark. Now, in order to balance it again, we need to find the position from where a 75-gram mass has to be suspended. I have a 75-gram mass here. Where should it be suspended? That's the question we need to answer. Well, let's figure out where that is going to be. That's too far. Am I getting a balance there? Almost. I've got the balance. So you need to suspend the 75-gram mass from, let me read, I got the 80 centimeter mark, the 80 centimeter mark. Now, I decided to show this to you to talk about it. You can see what is happening now. If you would take the torque of all the forces, tell me what are the forces acting on this meter rule? The weight of the meter rule is acting vertically down at its center of mass, and the normal force applied by the pivot is upward, and those two forces actually cancel. Then there is a force pulling the meter rule down here, the force due to this 100-gram mass. What is that force? The weight of this 100 gram. That is 0.1 kilogram times 9.8. So this is 0.98 Newton. And here is, we have 75 gram at the 0.80 centimeter. Tell me, what is the torque of this force, the 0.98 Newton, about an axis through the pivot? What is the torque of this force about an axis through the pivot? It will be that force multiplied by this torque arm, which is, this is 25 centimeter mark, the center of mass is 50 centimeter, so the distance is 25 centimeter. So 0.98 multiplied by 25 is that torque. Now tell me, is that torque a clockwise torque or a counterclockwise torque? When you are looking at it, I'm going to stand the way you are going to look at it. So the torque of this force will be, this is the pivot point. it will be rotated, look at the way my hand goes, in the clockwise direction. The torque of this will be a clockwise torque, 0.98 multiplied by 0.25. Alright, what is the torque of this force? Now the mass is 0.075 kilogram, multiply that by 0.98. That will be the force. What is the torque arm? This is the 80 centimeter mark. The pivot point is 50 centimeter. So 80 minus 50 is 30 centimeter. The torque of this force will be the force multiplied by 0.3. What kind of a torque is this? This is the pivot point. The torque will be counterclockwise. So if this is a positive torque, this is a negative torque. Tell me, what is the torque of the weight of the ruler about an axis through the same point? The torque of the weight of the ruler and the reaction force, both that will be zero because the torque arm is zero. There are only two torques. Therefore, sum of the torques, you can solve this problem by setting the sum of the torques equal to zero. Alright, let's do, here we have the meter rule pivoted at the 0.5 centimeter mark at its center of mass, at the pivot at A. Let's mark the different forces acting on the meter ruler. What are the forces acting on the ruler now? The weight of the ruler will be acting vertically down. And what is the weight of the ruler? It will be its mass times acceleration due to gravity. The weight of the ruler, mg, will be acting vertically down, and the normal force Fn will be acting vertically up. Well, the weight of the 100 gram, where is the 100 gram suspended from? From the 25 centimeter mark. And what is the weight of the 100 gram? It will be 0.1 kilogram times 9.8. 0.98 Newton is acting from the 0.25 centimeter mark. And now we have to find the position from where a 75 gram mass to be suspended on the other side so that the ruler will balance again. What is the weight of the 75 gram? 75 gram is 0.075 kilogram times 9.8, that is 0.735 Newton. And the 0.735 Newton is at the point X, and we need to find that point X. Okay, now all these forces are Y forces. So we apply the conditions there, the sum of the Y forces, which is Fn upward minus 0.98 minus mg minus 0.735. Now this is the sum of the Y forces. There is only one positive force upward, that's Fn. So Fn minus 0.98 minus mg minus 0.735 must be equal to 0. This is summation of all the Y forces equal to 0. So that is one condition. Okay, but that will not solve our problem, does it? We need to find the value of X. Now, we now choose a point so that the torque of all the forces about this point may be taken. Now, we have several points here. The end of the meter rule, the 0.25 centimeter mark, 0.5 centimeter mark, that's the pivot point, the X centimeter mark, and the 1 meter mark. Now, tell me, which of these points is the most convenient point we can take the torque of all these forces? the most convenient point is the point through which maximum number of unknown forces are passing. If you now notice the force mg, we don't know the weight of the ruler. Mg is an unknown force. Fn, the normal force, is an unknown force. And both these forces pass through A. Therefore, an axis passing through A is the most convenient axis. Why? Because the torque of mg about an axis passing through A is 0. The torque of Fn about an axis passing through A also is 0. So, the best choice for this purpose is a point through which the maximum number of unknown forces pass, and that is point A, because both mg and Fn pass through A. That means the torque of mg, the torque of this force mg about an axis passing through A is 0. Why? Because the torque arm is 0. Similarly, the torque of Fn about an axis that passes through A is 0. What is the torque of 0.98 Newton about an axis passing through A? It will be the torque arm, which is 0.5 minus 0.25. Is that right? This distance is 0.5 minus 0.25. That is the torque arm. Multiply that with the force, that is 0.98. And that is 0.245 meter Newton. And that is the torque of 0.98 Newton about A. And is that a clockwise torque or a counterclockwise torque? You can see this force will rotate the ruler in a counterclockwise direction. Therefore, that torque is positive. Now, the torque of 0.735 Newton. What is the torque of this force about an axis passing through A? It will be, what is the torque arm? This is x centimeter mark. This is 0.5. So that distance will be x minus 0.5. That is the torque arm, multiplied by the force 0.735. The torque of 0.735 Newton about A is the torque arm x minus 0.5 times 0.735, and that torque is a clockwise torque, and a clockwise torque is negative. Is that right? A clockwise torque is negative. Alright, very important to identify the sign of the torque. Now, summation tau equal to, what is the sum of the torque? Adding the two torques give you 0.245 meter Newton minus x minus 0.5 times 0.735. Add the two torques and that must be equal to 0. And now, this is a simple equation that contains only one variable. You can distribute that. That will be 0.245 minus, see, you got to multiply here, minus 0.735x. And these two minuses will make it positive, plus 0.735 times 0.5 is 0.3675. So distribute and now simplify, and that gives you x equal to 0.83 meter. The 75 gram mass will balance the ruler when it is placed at 0.83 meter, which is 83 centimeter. Do you remember the value I got when we did the experiment? I got the 80 centimeter mark. Well, there can be small errors in the experiment. So that is the reason why we got the 80 centimeter mark. Alright? Now, these kind of problems are typical in this section. So you must be very familiar with these kind of problems. The second part of the problem is we need to find out what mass has to be suspended from the 0.9 centimeter mark, from the 90 centimeter mark, so that the ruler will be in equilibrium. Let's start by saying let M be the mass that needs to be suspended from the 90 centimeter so that the meter rule will be in equilibrium. Now, when M grams is suspended from the 90 centimeter mark, what is the weight of that M gram? The weight of that M gram will be that M multiplied by G. G is 9.8, so that weight will be 9.8 M. The force acting down at the 90 centimeter mark equal to mg, that is 9.8 M. Now we take the torque of all the forces about the point A. Now you know how to take the torque of these forces. First of all, you know the torque of mg about A is 0, and also the torque of Fn about an axis that passes through A is 0, because both these forces pass through that point. And the torque of 0.98 Newton about A is this distance, which is 0.5 minus 0.25 times 0.98, and that will be 0.245 meter Newton. We did all that in the previous case. Now, this is a counterclockwise torque, therefore it is positive. What is the torque of this force? 9.8 M about A. What is the torque arm? The torque arm is 0.9 minus 0.5. That is this distance. So it will be 0.9 minus 0.5, the torque arm, multiplied by the force. Force is 9.8 M. And this is a clockwise torque, which is therefore negative. So we have a positive torque of 0.245 meter Newton and a negative torque of how much? 0.9 minus 0.5 times 9.8 M. Using summation tau, add the torques 0.245 plus negative, that becomes minus 0.9 minus 0.5 times 9.8 M equal to 0. The two torques added should give you 0. And now distribute. You have 0.245 minus 0.9 minus 0.5 is 0.4, and 0.4 times 9.8 is 3.92. So 0.245 minus 3.92 M equal to 0, or M equal to 0.0625 kilogram. It means in order to balance the ruler, you need to suspend a mass of, how many grams is this? 62.5 gram from the 90 centimeter mark. Okay, that again is a terribly important kind of problem. Before we proceed to the next problem, I want you to look at some of the steps that we are going to use in solving problems in conditions of equilibrium. Now, step number 1 is identify the point or object in equilibrium. Now, in the previous problem that we did, it was the object that was in equilibrium. Which object? The meter ruler. That's right. The ruler was in equilibrium under the action of several forces. Once you identify the object, then draw force vectors. Draw vectors to represent all the forces acting on the object. That's what we did in the previous cases. We represented all the forces by drawing force vectors. Now, In some cases, the force may not be in the proper y or proper x. It may be at an angle like this. That means you need to resolve it as an x component and the y component. So if a force is in an arbitrary direction, making an angle theta with the x direction, you need to write it in the component form, or we say break it into x and y components. And then mark all the distances. Why is it important to mark all the distances? Well, in order to find the torque arm, we need the distances. So we have marked all the forces and now all the distances. Now apply the conditions of equilibrium. First condition, summation fx equal to 0, summation fy equal to 0, and so on, and form equations. And then find the torque of all the forces about any convenient point. Any convenient point means any convenient axis. And the point is the point through which the axis is passing. And what is the convenience here? The point you choose must be a point through which maximum number of unknown forces pass, so that the torques of those forces about that axis will be 0. And then use summation tau equal to 0 to form another equation. And then solve all the resulting equations for the unknown. And these are the steps. Once you are able to use these steps, you can solve any problem in conditions of equilibrium. All right. Now, those who particularly go for civil engineering, this skill is very important because this is part of statics. You will be doing a course called statics, and you will start with these kind of problems. So you must pay special attention to these problems. Let's try another problem. A 3-meter diving board which has a mass of 25 kilograms is fixed at 2 supports, one at one end and the other 1 meter from it. If an 80-kilogram man is standing at the free end of the board, find the reaction forces at the supports. Can you figure out how the diving board is fixed? It's not very difficult. Now this is how it's going to look. These are the 2 supports and the diving board is fixed on these 2 supports. Well, one is at one end and the other is 1 meter from it, and at the end of the diving board you have a man standing. And what are you supposed to find? You need to find the reaction forces at the 2 supports. In other words, what are the forces acting on this diving board by these supports? And that is what we need to find. I have a diagram of that diving board. We got the 2 supports and the diving board. The diving board is in equilibrium under the action of several forces. Can you tell me some of the forces? Well, the first thing you should consider is the weight of the diving board. Now, a 3-meter diving board which has a mass of 25 kilograms. The mass is 25 kilograms, therefore what is the weight? The weight of 25 kilograms is 25 times 9.8, that is 245 newtons. The weight of the diving board is 25 kilogram times 9.8 meter per second squared, that is 245 newton acting vertically down at the point C. The weight of the man, there's a man standing here, there's the man, and his mass is 80 kilogram. His weight will be 80 kilogram times 9.8 meter per second squared, and that is 784 newton acting vertically down. So that is another force acting on the diving board. Can you tell me what other forces will be acting on the diving board? Well, the supports will be exerting force on the diving board. Now, do you know in what direction will those forces be? Well, we will assume that the reaction forces at both supports are directed upward. Let R1 be the reaction on the left support, so that's R1. And let R2 be the reaction force at the second support. Now, you have now seen the diving board has been identified as the object in equilibrium under the action of all these forces. Now go back and have a look at the steps that we developed. Identify the object or point in equilibrium. Here it is the object, that is the diving board, is in equilibrium under the action of all these forces. What is the next thing to do? Well, mark all the points. We said R1 acts through A, so this is the point A. R2 acts through B, that is the point B. And 245 Newton is at C, and the man is standing at the point D. So mark all the relevant points so that we can now identify the forces from the points. And now we mark the distances of the forces from the point A. Now you know that the diving board is 3 meters long. That means the distance from point A, remember A is the left end. The distance from A to C is 1.5 meter. What is the distance from A to B? Is 1 meter, that is given. Alright, let's do that. The distance from A to D is 3 meters. That is the length of the diving board. The distance from A to C is 1.5 meters, half the length of the diving board. The distance from A to B is 1 meter. That is given to us that the supports are 1 meter apart. Now, all these forces are Y forces, isn't it? There are 2 forces in the positive Y direction, 2 forces in the negative Y direction. So we are going to use this condition, summation Fy equal to 0. Alright, can you give me that equation? Summation Fy equal to 0. Adding all the Y forces give you 0. It will be R1 plus R2 minus 245 minus 784 equal to 0. And that is one equation. And we can write it like this. R1 plus R2 equal to 1029. This is our first equation. And there are 2 unknowns, R1 and R2. So we need to look for another equation. Now, where is that second equation going to come from? We used the Y forces. Are there any X forces on the diving board? No, there are no forces in the X direction. So now what we need to do is take the torques of all these forces about any convenient point. Means about any convenient axis that passes through any of these points, A, B, C or D. Now tell me, which of these points is convenient for us? What is the definition of convenience I gave you? The most convenient point about which you can take the torque of the forces is the point through which maximum number of unknown forces pass through. Now here, A is a good point because R1 passes through A. That means the torque of R1 about A will be 0. B is also a convenient point because an unknown force R2 passes through B. Now we will choose A. I have chosen A, but you can do it by choosing B. Let's take the torque of R1. What is the torque of R1 about an axis that passes through A? Since R1 passes through A, the torque arm is 0. Therefore, the torque of R1 about A is 0. What is the torque of R2 about A? Remember, torque is the torque arm multiplied by the force. What is the torque arm here for the force R2? The distance between A and B is 1 meter. So that will be 1 meter multiplied by R2. That is the torque of R2 about an axis that passes through A, and that will simply be R2. Tell me, is that a clockwise torque or a counterclockwise torque? Have you figured out how to do this now? We are rotating the object about an axis through A, so point there and then draw a circle with the force like this. R2 rotates about this point counterclockwise. Therefore, it is positive. R2 is positive because that torque is a counterclockwise torque. The torque of 245 Newton. Tell me, what is the torque of this 245 Newton about A? It will be, the torque arm is 1.5 meter multiplied by 245, and that is 365.5. It is negative because that torque is a clockwise torque. Watch me trace out. It is a clockwise torque. So it is negative. What is the torque of 784 Newton about A? It will be, the torque arm is 3 meter multiplied by 784. That is negative 2,352 meter Newton. Why negative? Because that torque also is clockwise. Therefore, it is negative. There you are. And now, let's add all these torques. The sum of all these torques, what will that be? 0 plus R2 minus 367.5 minus 2,352 must be equal to 0. So, R2 minus 367.5 minus 2,352 equal to 0. And that gives you R2 equal to 2,719.5 Newton. So the reaction force on the second support is 2,719.5 Newton. Once you know R2, we can go to equation 1 and solve for R1. Let's do that. Using the value of R2 in this equation, R1 plus R2 equal to 1029, we get R1 equal to 1029 minus R2, and that R2 is 2,719, and that gives you a negative value for R1. R1 is negative 1,619.5. Now, what does that mean? What does it indicate that R1 is negative? You see, we assumed that the reaction force on this outer support is upward, but really no. You see, when this man is standing here, this force is trying to rip apart the diving board. Therefore, the duty of this support is to hold it down. The reaction force of this support is not upward but downward. Now you notice that even if you make a mistake, the method of the problem will correct us. So it doesn't matter if you assign a force in the wrong direction. If you use the correct method for solving the problem, the method of the problem will correct you. So what is the value of R1 now? R1 is 1690.5 Newton directed downward. Okay? Let's go and solve another problem. An 18 Newton weight is supported by a cable attached to a 2-meter strut hinged at a point A as shown in the figure below here. So what's that again? An 18 Newton weight, this is the 18 Newton weight, suspended by a cable attached to a 2-meter strut. This is the 2-meter strut, and it is hinged to a support there. The strut is supported by a second cable. The strut is supported by a second cable under a tension T. The mass of the strut is 5 kilograms. So the mass of this beam, if you want to call it, is 5 kilograms. Now what are we supposed to find? What are the 4 forces acting on the strut? Well, I specifically said there are 4 forces. What are the 4 forces acting on the strut? Find all the 4 unknown forces. Can you talk about the forces acting on the strut? What are these forces? Well, there are a couple of forces very obvious. One force is the weight of this object, that is 18 Newton acting vertically down as one force. This is the tension force acting at an angle 30 degrees. Second force. What is a third force? A third force is the weight of the strut. Where is the point through which it is acting? At its center. So the weight of the strut will be acting vertically down. What is the fourth force? There is some kind of force at the hinges. We don't know in what direction the force is. And therefore, now look at the way we are going to approach it. We don't know the direction of the force at the hinges. So we are going to say, let it be in any arbitrary direction. Let the force at the hinges be somewhere in that direction. In any direction. Now, in such a case, it has a horizontal component and a vertical component. So mark those components. Let its horizontal component be called H and the vertical component be called Y. So we are now going to say whatever force exists at this hinge is now broken into a horizontal component H and a vertical component V. Once you are able to find H and V, we know how to find that F. Is that right? I'm sure you know it. Alright, what's the method we are going to use? Okay, let's now solve this problem. The strut AB is in equilibrium under the action of these several forces we just talked about. So the first thing to do is, let's isolate the strut and draw a separate diagram. This is the strut. And let's draw the diagram of draw the various forces. What are the forces? This is the point A, that's the point B, and C is the center of the strut. That's your C. The weight of the strut is its mass times G, 5 kilogram times 9.8 meter per second squared, is 49 Newton, will be acting vertically down. The weight 18 Newton, remember this is given in newtons, not in kilogram, so you don't need to do anything with it. this 80 Newton will be acting vertically down from the point B. Now, the tension T on the supporting cable, this is the tension T, and the angle it makes with the strut is 30 degrees. Remember, it is not the angle it makes with the positive x-axis. It is the angle it makes with the strut. Alright. Now, the hinge at A exerts a force on the strut. Since we are not sure of the direction of such a force, we assume that this force is made up of a horizontal component H and a vertical component V. Now that's a very neat way to approach when you don't know a force. So let the force at the hinge be represented by its horizontal component H and the vertical component V. We now resolve this tension force into the horizontal and vertical component. Now tell me, can you use this 30 degrees and tell me what is the horizontal component of that T? The horizontal component is T cos 30 degrees. So this is the horizontal component, that is T cos 30 degrees. And what is the vertical component? The vertical component is T sine 30 degrees. There you are. And now you have all the forces in the proper directions. Look at this. V is the positive y direction. T sine 30 is in the positive y direction. 49 Newton negative y direction. 80 Newton in the negative y direction. We have also some x forces. What are they? The force H is in the positive x direction. The force T cos 30 degrees in the negative x direction. Alright. H and T cos 30 degrees are x forces. H is a positive x force. T cos 30 degrees is a negative x force. So, if I now use this condition, summation fx equal to 0, what does it mean? It means add all the x forces and set it equal to 0. It means positive h minus t cos 30, isn't it? This is negative. So h minus t cos 30 degrees equal to 0. We produced one equation. And write it like this. H minus 0.86 t equal to 0. You got one equation having unknowns h and t. And now, let's look at the y forces. Summation Fy equal to 0. What are the y forces? V is a positive y force. T sine 30 degrees is a positive y force. 49 a negative y force. 80 Newton a negative y force. So it will be V plus T sine 30 degrees minus 49 minus 80 equal to 0. There we have summation Fy equal to 0 gives me this. And let's simplify this. This will be, can you tell me, sine 30 degrees is 0.5. So it will be V plus 0.5 t, and take the negative 49 and negative 80 to the other side, we get this equation. V plus 0.5 t equal to 129. You can see we have two equations, but can we solve these two equations? We got three unknowns. So we still cannot solve these equations. We need to get one more equation. Now tell me, where is that equation going to come from? It's going to come from summation tau equal to 0. In other words, we take the torques of all these forces about any convenient axis. Tell me, give me a point which is the most convenient. I want you to watch here. Watch this point A. The force H passes through A. The force V passes through A. And watch this. The force T cos 30 degrees also passes through A. That means if you take the torques of all the forces about the point A, the torque of H will be 0, the torque of V about A will be 0, the torque of T cos 30 degrees about A will be 0. Look at that. We have 3 forces passing through A, and because the torque produced by each of these forces about an axis through A is 0, we will eliminate that from our equation. You see, that is a neat strategy. Alright, we now take torques of all the forces about the point A. You know why I chose point A. Alright, let's write down that. The torque of the force V about A is 0 for obvious reason. The torque of H about A also is 0 because H also passes through A. And the torque of T cos 30 degrees about A is 0 because that force also passes through A. The torque arm is 0. Well, the distance from A to B is 2 meters, the length of the strut. The torque of T sine 30 degrees about A. Look at that. T sine 30 degrees is this force. What is the torque of this force about an axis passing through A? The torque arm is this distance, the perpendicular distance. That will be 2 meters multiplied by T sine 30 degrees. And look at the way I simplified it. Sine 30 degrees is 0.5. 0.5 multiplied by 2 is 1. 1 multiplied by T is T. So that torque is T meter Newton. Now this is a counterclockwise torque. Look at that. The torque of this force about A is a counterclockwise torque. Therefore, it is positive. Okay. What is the torque of 80 Newton? What is the torque of this force, 80 Newton about A? The torque of 80 Newton about A is the torque arm is 2 meters multiplied by the force is 80 Newton. It will be 2 multiplied by 80, but that torque is a clockwise torque. Therefore, it is 2 meters times 80, and that is negative 160 meter Newton. A clockwise torque is negative. Alright, what is the torque of the 49 Newton? You can see 49 Newton is at the point C, and the distance of that C from the point A is half of this 2 meters, 1 meter. What is the torque of 49 Newton about A? It will be the torque arm is 1 meter multiplied by 49 Newton. That will be negative 49 Newton. Why negative? Again, the torque of the 49 Newton about the point A is negative. It's a clockwise torque. Alright, let's now add all these torques. Summation of all these torques will be 0. Look at that. T minus 160 minus 49 equal to 0. That is what you get by applying summation tau equal to 0 is T minus 160 minus 49 equal to 0, and that gives you the value of T right away. We've got the value of T, and once you have the value of T, you can take it to equation 1 and you can get the value of H. So using this value of t in h minus 0.866t equal to 0 gives you h equal to 181 Newton. I just used the value of t there. So we solved for t, we solved for h. We now need to solve for v. That means take the value of t to your second equation. Let's do that over here. This is the second equation. V plus 0.5t equal to 129. Now in this equation we replace this t by its value we calculated, which is 209 Newton. So that will be V equal to 129 minus 0.5t. That will be 129 minus 0.5 times 209. That is 24.5 Newton. Well, we've got V equal to 24.5 Newton and H equal to 181 Newton. Look at the way I've drawn these vectors now. I drew my H vector and I drew my V vector from the head of H. You see, as long as you have the same direction and the same length, a vector can be drawn anywhere. So we have H and V. Can you find the force at the hinges? Well, if F is the force at A, at the hinges, then the magnitude of that F will be the length of this vector will be square root of H squared plus V squared. Well, H is 181, V is 24.5, and that gives you square root of 181 squared plus 24.5 squared is 182.7 Newton is the force at the point A, the magnitude of the force. Well, we also need to find that angle. How do you find the angle? Tan theta equal to, or theta equal to tan inverse of y over x. That's right. So if theta is the angle F makes with the strut, that is this angle, then tan theta equal to V divided by H. That is 24.5 divided by 181. That is 0.135. Therefore, theta equal to tan inverse of 0.135. That is 7.7 degrees. So we now obtained all the forces acting on the strut. The tension T is 209 Newton. The force acting at the hinges is F equal to 182.7 Newton at an angle 7.7 degrees. Isn't that a beautiful problem? I'm sure you enjoyed it. So please try and do this couple of problems like this on your own. I have given you a couple of problems like this in the homework. Okay. There you are. Let's do another problem. A uniform meter stick weighing 5 Newton is pivoted so that it can rotate about a horizontal axis through one end. Well, a meter rule is pivoted like this, means it can rotate about a horizontal axis. Look at this. This is the axis, that is horizontal. And the rotation, you can rotate about that horizontal axis. It is pivoted here so that it can rotate about that horizontal axis. If a 0.15 kilogram mass is suspended 75 centimeter from the pivoted end, what force must be applied at the free end of the meter stick to maintain it in a horizontal position or to maintain it in equilibrium? Can you picture that? It's very important to make a picture in your mind. a meter rule is pivoted at its 0 point at one end. Now, what is done here? The meter stick is pivoted at A. Its weight is acting vertically down. Now, you got to read the question very carefully. Sometimes I give you the mass of the ruler. Then you got to figure out the weight as mg. But here I give you the weight. It is 5 Newton. So the weight of the ruler is 5 Newton. It is acting vertically down at the 0.5 meter mark. This is the 0.5 meter mark. So that means that distance is 0.5 meter. The weight of 0.15 kilogram, we have a 0.15 kilogram mass suspended at the 75 centimeter mark. Now, what is the mass of this 0.15 kilogram? It will be 0.15 kilogram times 9.8 meter per second squared. That is 1.47 Newton acting vertically down. And what is this mark? This is the 75 meter mark, 0.75 meter mark. So this distance is 0.75 meter. Okay, we are looking for the upward force. You can see this is the pivot point. That means the weight of the ruler is rotating it clockwise. This 1.47 Newton also is rotating it clockwise. In order to balance it, you need a counterclockwise torque. And that is going to be provided by a force that is applied at the free end. We need to find that force. What force must be applied at the free end so as to maintain the horizontal position? We need to figure out what the magnitude of that force is. Well, okay, the distance of this force from the pivot point is, what is that distance? It is the length of the meter rule, which is 1 meter. Alright, what all we need to do is find the torques of all these forces above the pivot point. So, let's find the torque of 5 Newton about an axis that passes through A. You can see the horizontal axis there. Now, what is the torque of this 5 Newton about A? It will be this torque arm times 5 Newton. 0.5 meter times 5 Newton, which is a clockwise torque and therefore negative. And that is negative 2.5 meter Newton is the torque of this 5 Newton about A. Similarly, what is the torque of 1.47 Newton about an axis through A? It will be, the torque arm is 0.75 multiplied by the force is 1.47, and that is a clockwise torque. You see, a clockwise torque, therefore that is negative 0.75 meter times 1.47. That is negative 1.1 meter Newton. Alright, what is the torque of the force F about the point A? The torque of F Newton about A, the torque arm is 1 meter multiplied by F, 1 meter multiplied by F, and that is a counterclockwise torque. That is equal to F times 1 is F, that will be F meter Newton counterclockwise, and therefore it is positive. And to solve the problem, what all you need to do is add all the torques and set it equal to 0. Summation of tau gives negative 2.5 meter Newton minus 1.1 meter Newton plus F equal to 0. negative 2.5 minus 1.1 plus F equal to 0. You can see you can find F from there straight away. F equal to 3.6 Newton, and that is the force that you needed to balance that meter rule. Well, I think we did a few very good problems, and I want you to review them. Do them a couple of times on your own and practice so that you can do problems like this. Alright, I think we have now come to the end of Unit 4 of the course, and you should be now ready to take your Unit 4 test. Alright, again let me tell you, do the practice test first, and then make sure that you can actually do all the questions. And please take the test before the expiry date. Alright, I will get back to you with Unit 5 later.